Hi, this is Matt Reed from the University of Michigan. I'm going to talk to you about the HumanShape app, which is a new way to use anthropometric data in design. This is the very short version. We've got a new online app. It's focused on 3D analysis for anthropometric data, that is body size and shape, with a specific focus on making the data useful for design. Over the years, we've gathered tens of thousands of high-resolution scans of adults and children and developed innovative techniques to make those data available in a much more usable format than is typical. This new online tool is available for use by designers, clothing, personal equipment, anything that involves interaction with body size and shape. So this is a little background. I, those of you who have worked with anthropometric data, and if you're watching this, I'm guessing that you have, you know that the options are pretty limited. Somebody comes to you and asks you how big to make a pair of glasses, how big to make a helmet, how big to make up some body armor or shoes, or really anything that goes on the body. You need to look for anthropometric data for body size and shape information. And when you do that, you find that the options are very limited. You ask your favorite AI tool, and it'll give you data that's really not relevant for your population. So, what we're trying to do is take anthropometry, really drag it into the 21st century so that we're using the multivariate analysis, exploiting the 3D data to the extent that we can, and applying the data from the right population. This is a problem that has been around a long, long time. I encourage you to take a look at this publication from 1952. This guy, Gilbert Daniels, I think it was Captain Daniels, demonstrated using some of the first data on aircrew that it's really not possible to do a multivariate analysis in advance. You need to know which dimensions are relevant to your design, and then you need to go to the real data, not some tabulated information in the back of a book. And yet, in spite of this work being done many, many years ago, the application of anthropometry in the 21st century is still very much stuck in the 1950s. Now, most of you are aware that three-dimensional scanning data are available. You've seen it being used to make avatars for entertainment and maybe in your industry for product design. However, scan data is really rarely used and even more rarely used well. And the problem is you can buy a scanner, a really good scanner now for a few $1,000s or even less, and gather scan data, but actually doing anything useful with it is very challenging. There's the basic things having to do with anthropometric surveys, like recruiting the correct population, and appropriately doing appropriate statistical analysis, of course. But we've got a lot of other problems that are unique to 3D data. And the biggest problem is that there are very few software tools available to do anything useful with it. And that's where we are targeting this effort. This is an example of a head scan from the Caesar data set, which is a really widely used whole body data set. This is data set's almost 25 years old, but is still really widely used because it's one of the few data sets that has both manually measured dimensions relevant for clothing and equipment design and three-dimensional scans. But you can see the typical problems here, and really these don't go away even with higher quality scanners of today. The 3DMD scanner, for example, routinely will generate noise and gaps and holes in the data set. And most importantly, it's an unstructured mesh and typically not in a useful coordinate system. Now, if you go looking for software to work on with data like this, you're going to find very little, even from the manufacturers of the scanners, because their applications tend to be focused on individuals rather than populations. Well, in our group, we have gathered over the years, been doing this work for 25 years and more, thousands and thousands of whole body scans from our own studies, from other studies, data that we've gotten from collaborators. And importantly, we've developed a lot of modeling technology. I'm not going to talk extensively about our template fitting and statistical modeling here. In another video, I'll give you an overview of some of our papers on that. But we've worked hard on this methodology that allows us to create accurate models of the scan data that make it possible to use. So, what's the app about? Well, some years back, we launched HumanShape.org, which is a website that allows people to manipulate statistical shape models. And we found that while that was useful, it didn't give designers what they really needed, which was the ability to actually measure the population, to take a particular human dimension, extract it from a population, compute statistics, and so on. So what we're aiming for is any dimension that you can define on a population, use a relevant population, allow the avatars to be posed, and then do multivariate statistical analyses. And in another video, I'll talk about the design wizards that we're developing to allow even novices to conduct accurate analyses for common design problems. So the idea behind the Human Shape app is to give access to a very powerful suite of tools. Very few of these tools are available in any software, but we're making it available online in a unified way that allows people to use many different populations and different models, head models, hand models, so on, without having to do any software installation. And it also allows us to quickly create, for example, bespoke populations. If you need a particular population, chances are we can generate it if we don't already have it. And importantly, you're going to see a lot of pictures in this video that look like people's faces. These are entirely synthesized so that even though the models capture all the relevant variability in the faces, they're not identifiable people. So I'm going to talk now about the functionality of the tool. And one of the key things is the ability to define the measurements that matter for a particular design. You can pick up a design textbook and look in the back, and it'll tell you a whole bunch of numbers. You've got numbers there for standing height and erect sitting height and buttock popliteal length. Now, those are probably not relevant to your particular design. Probably that posture is never relevant to a design. But what you need are the dimensions that are particular to your problem. And so this tool is designed to allow you to make any dimensional measurement you want, straight lines, curves, circumferences, and then immediately compute that across the population. We're also able to generate statistical models that generate the whole body size or whole body shape rather based on the input dimensions. So for example, if you're designing glasses, you might want to create some head forms that are based on the fore-aft distance from the nose to the ears or the width of the nose and so on. Well, you can do that in this tool. We're not aware of any other tool that would allow you to do that. You can also upload and manipulate some reference geometry. I put some glasses in this scene just to demonstrate that. It's geometrically correct, so you can look at how different head sizes and shapes, in this case, relate to the size and shape of your product, different sizes and so on. And you can conduct multivariate accommodation assessments on the dimensions that you defined across the full population.